Hi friends, welcome to Beginner's Answers for Heat Transfer. In this episode, we are going to define the simplification process in ANSYS. Every engineers are managers. Our aim is to minimize the usage of resources and increase the efficiency. In this video, I am going to show a simplification method for the same problem that we just did. So let's start. The same problem that we just did in 3D can be converted into 2D by considering only the cross-section of the window. This reduces the computational time as well as the resources used. For a simple problem like this, the computational time difference and the resources used won't matter much, but for a complex one, this will affect the time taken for solving the problem. So in this video, I am going to try to solve the 2D structural analysis of the same window pane. First, go and set the preferences to thermal. Click OK. In the preprocessor, we are going to select an element type. So first go find the best element. Go to Basic Analysis Guide, Defining Element Types, Many Element Types. Click on Plane. So from the list, 4-node 2D space with degree of freedom temperature is plane 55. So we are going to select that. Go to element type, add, edit or delete elements, adding elements. The plane elements also comes under solid condition. So solid quad 4-node 55 is the same as plane 55. Give the reference number as 1 and click OK. So that element is added. Now go to material properties, material models, thermal conductivity. For the isotropic case, our thermal conductivity was 0.6. Click OK. Close it. Now we are going to model the cross section. So go to modeling, create. We can create an area which is a rectangle by 2 corners. So we are starting at 0, 0 and the width is 0.3 and the height is 6 meters. Click OK. So this is the cross section. Now let's go ahead and mesh it. Go to mesh tools. So we can go with hexagonal quads. Click on it. Click the structure. Click OK. So it is meshed. Now let's go to the loading conditions. Define loads. Apply temperature. Analogous to the areas that we applied temperature on last time, we can apply on lines this time. So click on lines, select this line on one end, click apply. So we didn't close the mesh tool, close it. Temperature at that end it was 289.15 Kelvin as constant value. Click OK. Then again on the other side we are selecting this line, click apply. At that end it was 279.15. Click OK. Now go to solutions, solve the current load step. So here we can see it's a static case and we can click OK. If you go to the general post processing, plot results, counter plots, nodal solution, and we are plotting for the degree of freedom solution, that is the nodal temperatures, and click OK. We can see the same gradient that we saw for the 3D case, but in this case it is only a 2D. If you are going to the element solution to find the thermal flux, we click on thermal flux vector sum and click OK. we can see that the same value that we got for 3D case can be obtained here. So in the 3D case, we calculated with 8 nodes, which was reduced to 4 nodes in the 2D case. The second thing is, the machine created lesser number of elements, thus lesser number of nodes in totality. So the calculation time as well as the resources that we used for the process reduced considerably in this case. This kind of simplification techniques can be applied in many different cases. Some other simplification methods like symmetry cases are discussed in our future videos. The basic course for the series ends here. An advanced course for the same is available. Thank you all for watching the series and wish you all a happy and prosperous future. Thank you.